basics of physical geography, the geography before landforms, and then we'll move on to climate. We'll move on to climate. I'll do climate briefly, and mostly we will try and focus on understanding that through questions. Okay. And I hope the last thing we covered in the previous class was the diagram of the various discontinuities in the earth. So I hope that diagram was clear. I'm also going to try and find a more efficient way of sharing pictures. Hopefully that will also work out. Okay, so let's continue. So another important area is the types of volcanic volcanic landforms. Okay, so volcanic landforms, we have batholiths, laccoliths, lopoliths, phacoliths, sills, and dikes. So you need to be able to identify the differences between all of these. The way I did this is by making diagrams for each of them. Okay, so batholith is a large volcanic form which is deep beneath the surface, and it's a large reservoir of magma and lava. Sometimes that reservoir, when there's denudation meaning the process of removal of all the material which is above the batholith becomes visible. Okay, and the important thing in terms of the exam is that batholith is made up of granitic material. Batholith is made up of granitic material. So largely there are two types of material that landforms can be made of: basaltic and granitic. Basaltic is largely from the ocean, and granitic is associated with landforms and magma. So batholith is a granitic landform, and it is a large body of lava. Laccolith is shaped like a dome. Laccolith is shaped like a dome with a base and a pipe-like structure. Actually, I haven't tried this before, but please be patient with me. Let me see if this works out. Give me a second. I wanted just try something and see if I can share this. Okay, so I'm sending you all a link. Let me see if that can. I've sent a link. Is it accessible? Can you see? Can everyone see? Nobody can see. Are you opening it on Google, or are you opening it on? Okay, so it's not working properly. Fine, then leave it. Then leave it. I'll just explain it. I'll just explain it. I can't share the whole screen. I'm not comfortable sharing the whole screen in case any detail. Okay, but fine. Let me just explain it without the demonstration. Because I mean, it's working for some people, it's not working for everyone, so it's unfair. It's not fair for me to do it if it's not working for everyone. So let me just tell it verbally. Okay, so at least laccolith, you will have a saucer. You will have a dome shape, and with the dome shape, you will have lava which is coming from the bottom. So this dome shape with a pipe at the bottom is known as laccolith. I'll just share the diagram. From the diagram, you'll be able to understand. I'll share the diagram with everyone. And yeah, fine. At least this link is opening. Fine. So on this link, just try and understand what these various volcanic forms are. So from this, has everyone opened the link? Okay, everyone's opened the link. So you have a batholith. Batholith is this huge volcanic form at the bottom. Okay. Then you have laccolith. Laccolith is saucer shaped. This saucer dome shape with lava from the bottom. Sill is if it is going horizontally into these small gaps in the sediment. Then you have syncline, anticline. Syncline is the one which is shaped towards the bottom. Anticline is shaped towards the top. Okay, and lopolith is this saucer shape with the bottom. Okay, I've sent the link on chat. I'll send it again if you want, and just make sure you revise this. Revising this will give you, just looking at this picture is enough. You'll understand what these landforms are. Okay, so these are volcanic landforms. Just need to remember that what these look like, what the differences are between them, what the shapes are. So possible question, what kind of question can be asked from this area? Okay, possible question can be match the following, like lapolith, locolith, saucer shaped. It is found in the sedimented spaces between land, or this is the large intrusive form, or these are the vertical intrusions, which are dikes. So like that, you can have all these names and these types. So you need to just remember what each type and each shape corresponds to in case there's a question in static. And lastly, what you need to try and like remember slightly are names. What are the types of volcanoes and which types are present in India? Okay, so you have shield volcanoes. Shield volcano is largely made up of basalt. Okay, remember we said that batholith is granitic. Shield volcano is made up of basalt, and basalt shield volcano is basically very long but low height and very long. An example of shield volcano is Mauna Kea in Hawaii. I'll send the spelling. Example of shield volcanoes, Mauna Kea in Hawaii. So shield volcanoes basically are not explosive. They are not explosive. They are mostly very they emit large volumes of lava, but without explosion. Large volumes of lava without explosion. Contrasting with this is composite volcano. Composite volcano is granitic. Composite volcano is granitic, and it is very explosive. Composite volcano is granitic, very explosive, and it is formed in layers. So granitic volcano, also known as composite volcano, has high height, but not as much width. So it is said that the Deccan Plateau is a shield volcano. They say that Deccan Plateau is a shield volcano, or also a flood basalt province. Shield volcano, if it is there in like large quantities, large areas, then it is known as flood basalt province, and that is the Deccan Plateau. So these broad areas, shield volcano, composite volcano, differences you need to know. Shield volcano, composite volcano, these differences, granitic versus basaltic types of lava, in terms of height, in terms of explosivity. These are also like composite volcano example is Mount Fuji. Mount Fuji in Japan. Mount Fuji in Japan. Mount Fuji in Japan. Okay. And there's a very specific type of composite volcano known as caldera. Caldera, this term, just remember the term caldera. 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 So caldera is when explosion that happens is so explosive that the volcano itself collapses. If the explosion of a volcano is so explosive that the volcano itself collapses, leading to the formation of a crater, that is a caldera. Okay, so these are volcanic forms. We're going to move on. So basically that volcanic intrusive forms, there are landforms associated with volcanoes we've done, and we've looked at the differences between volcanoes. Both are important areas for prelims because they can be very tricky. It can be very tricky. You need to know the exact difference between, like when I'm saying these granitic, basaltic, you need to know the differences. Okay, like just as a short question, which one is more explosive, granitic or basaltic? Just type it out in chat quickly. Which type of lava is more explosive? Fine, yeah. So granitic more explosive, basaltic less explosive. And granitic, you need to understand that granitic, if you want the concept for why granitic is less explosive, it's because granitic cools down faster, is more explosive. Granitic cools down faster, and because it cools down, every time the volcano erupts, it is breaking the cooled portion of magma. Granitic is more viscous, it is more thick, okay? And basaltic is less viscous. Basaltic is very liquid. It becomes solid very slowly. So all the magma comes out, it spreads into large area, and then it cools down. But granitic, what happens? It is very thick. It condenses, it becomes solid very quickly. So every time there's an eruption, it happens very violently. So viscosity, the explosiveness, granitic, basaltic. Granitic comes from the lower layers of the crust. Basaltic comes from interior layers of the crust. These differences you have to remember, and this is also how the volcanoes themselves are formed. If you remember this, any conceptual question related to this you can solve. You can eliminate, you can reduce options, you can do all that. Okay, so that way this concept is very important, like don't forget it. Fine. So let's move on to the next section. Next section is about the continental drift theory. Continental drift theory. On continental drift, there are 5 proofs. There are 5 proofs for continental drift. I'll just recap them for you. Okay, I'll recap those 5 and then we move on. So first is the jigsaw fit. Jigsaw fit says that because Africa and South America can fit with each other, because they can fit with each other, there was a proposal that at some point these two continents must have been part of each other, because they're fitting exactly, they're fitting with each other. Okay, so that is known as jigsaw fit model. Second is that across the ocean, across the Atlantic Ocean, rocks of the same age are found in both South America as well as Africa. Rocks of the same age are found across South America as well as Africa, meaning that if rocks of same age are there, it must mean that the rocks belong to the same period, and at some point the continents must have been together. And third is tillite deposit. Tillite is associated with glacier. Tillite is a technical geographical term which means glacier. Okay, tillite deposit is is also known as moraines, also known as the eroded debris associated with glaciers is known as tillite. Okay, at some point during the ice age, if you remember, there used to be an ice age. There have been some movies also by Pixar called Ice Age. When the entire continent was covered, all land was covered by ice. Tillite from that time, tillite from that ice age time is common to both the continents, suggesting that the continents must have been together at some point. Okay, then you have plaque deposits. Plaque is associated with gold. Okay, and the reason I'm telling you all this, okay, like these terms, tillite, plaque, they're all important because UPSC will not ask direct question. UPSC will never ask which of the following types, which of the following are proofs for the continental drift theory. You will not find such a direct question in UPSC prelims. It has never happened. Okay. Instead, they'll take these terms. They'll take tillite, they'll take plaque, they'll put it in other contexts. They'll put it in the question. So you need to understand what these terms mean. If you know what these terms mean, you can eliminate options. You can try and solve the question. Okay, so these terms are very important. Term is plaque. Okay, I'll send the spellings for these 2 terms, tillite and plaque. Okay, tillite means glacier. Tillite is associated with glacier. Plaque is associated with gold. Okay, supposing tomorrow there's a question on which of the following countries are known for the plaque deposits. Okay, that basically means gold. Okay, plaque means gold. You should not get confused between what does that term mean, because this term is there in NCERT. If this term is there in NCERT, it means you are expected to know. That's all. Okay, so plaque deposits are there in Western Africa. Ghana, country like Ghana, is very renowned for gold, but the source of the gold is in Brazil, suggesting that the continents were once together. And lastly, fossils. Fossils of monkeys known as lemurs, 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 are found in India, Madagascar as well as Africa, suggesting that these 3 must have been part of the same continent at some point. So this is the quick recap of the 5 proofs. So then you have this a person known as Alfred Wegener. Alfred Wegener, again, I'll send the spelling of the name, Alfred Wegener. Person known as Alfred Wegener, what he did is he compiled all these proofs and then said that there was once a giant continent known as Pangaea. There was once a giant continent known as Pangaea and a giant ocean known as Panthalassa. Giant continent known as Pangaea. Giant continent meaning all the 7 continents put together. 7 continents put together called Pangaea. And a giant ocean combining all the oceans called Panthalassa. And he had some theories. He had some theories as to why this happened. UPSC has not asked any question related to this, but you should just be aware that there are terms known as pole fleeing force, known as tidal force. Okay, but these theories have been proven to be wrong. Wegener's theory for why these continents were all put together has been proven to be wrong. So we'll focus more on the actual continental drift theory instead of Wegener's theory. Okay. So next theory is by a person known as Arthur Holmes. Arthur Holmes. Next theory is by a person known as Arthur Holmes. Holmes gave a theory known as convectional current theory. Convectional current theory. Holmes gave convectional current theory. Convectional current theory, important fact to remember is it is due to two forces. Convectional current is caused by two forces. Radioactive elements in the mantle, radioactive elements in the liquid portion of the earth, radioactive elements, and primordial heat, meaning the heat which is present in the earth's core from the time of the Big Bang. Okay, primordial heat, the ancient heat which is still present in the earth's crust, that as well as radioactive decay of elements is responsible for, okay, both forces, both are responsible for the force. Okay, so what does convectional current theory say? Basically it says that the ocean flows are the are constantly spreading, rather that there is that because of this convectional current, the continental plates are constantly moving. I would have drawn a diagram and shown it, but that link is not working properly. So basically you have a convectional current which is moving upwards and out, and at some place they are converging. These currents are what are causing the continents to move. Continents are moving due to convectional current. Okay, and convectional current is caused due to radioactive decay and primordial heat. This is the concept. Concept is clear. We can move on to what are the facts. Facts associated with this are that you have the associated concept of sea floor spreading, which is given by Hess. Hess has given the concept of sea floor spreading, given by sea floor spreading. So sea floor spreading is based on five important facts. I'll recap them for you. First is that at the zone of sea floor spreading is where the most volcanic eruptions occur. At the zone of sea floor spreading, most volcanic eruptions occur. Second, either side of the volcanic eruption, age of the rocks is the same. Either side, the rocks are the same. Same age, same magnetic polarity. There is symmetricity. Okay. At the different distances from the volcanic eruptions, there is symmetricity. Third fact is that ocean crust is much younger than continental crust. Okay. Fourth is that sediments of the ocean is very thin. Okay. So for example, if continental crust is some 20 kilometers, I think, the sea floor crust is only around 2-3 kilometers. So layer of sediment itself, ocean crust is very thin as compared to continental crust. And fifth fact is that deep seated earthquakes happen at the interaction between continental and ocean crust. Okay, deep seated earthquakes happen at the interaction. This interaction area is known as mid-oceanic ridge. Okay, known as mid-oceanic ridge. So what does this theory say based on the five facts? Basically, at the center of the ocean, you have something known as mid-oceanic ridge. From mid-oceanic ridge, lava is coming out. What type of lava is coming out? Basaltic lava. Okay, basaltic lava is coming out. Basaltic lava is spreading the sea. You have sediments which are lining up. And as these sediments are spreading, they are interacting with the ocean. They are interacting with the continent, and at the continent, the crust is getting consumed in the trenches. In the trenches, the crust is getting consumed. So the crust is always young, the crust is always spreading, and there are constantly earthquakes at the center. There are volcanic eruptions at the center, and the crust is spreading, getting consumed, spreading, getting consumed, spreading, getting consumed. Okay, so this is basically the concept and the facts associated with that concept. Fine. Now, for the ocean itself, there are some important features in the ocean which you need to remember. Okay, some of these features are not there in the NCRT, so just try and follow and keep up. Okay, so first you have the continental shelf. Continental shelf is made up of the entire continental shelf is made up of the continental slope, continental rise, and the deep ocean trenches. So you have a continental rise near the land. Then you have continental slope, which as the continent gradually reduces, and then you have deep ocean trench. Deep ocean trench, I told you, is where the sea crust interacts with the continental crust. Okay, so that is the continental portion of the ocean. This is the under. So basically, you see, right, in a beach, the land gradually reduces, gradually slopes down. This is known as the continental slope. Okay. Next is something known as abyssal plain. Abyssal plain is the bottom of the ocean. Bottom of the ocean is known as abyssal plain. Abyssal plain has a lot of other features. It can have a feature known as Guyot, Guyot. This is not there in the NCRT, so I'll just write the spelling: Guyot, Guyot, known as Guyot. Okay, Guyot is basically if there is a protrusion. Supposing there's a column in the ocean, like a mountain-like feature, like a hill-like feature in the ocean, but that hill-like feature is under the water. It is known as Guyot. Okay, supposing there's a hill in the ocean which is under the water, it is known as Guyot. Next feature on the abyssal plain is a sea mount. Sea mount. Next feature on abyssal plain is sea mount. Sea mount is if there's a hill or mountain in the ocean which is coming out as an island, which you can see above the water. If you can see a hill or mountain above the water, it is known as a sea. It is known as a sea mount. Okay. And finally, in the middle of the ocean feature we have already spoken about, known as mid-oceanic ridge. Okay, known as mid-oceanic ridge. Mid-oceanic ridge is also known as the longest and largest mountain chain on the earth. Mid-oceanic ridge is the longest and largest mountain chain on the earth. Mid-oceanic ridge, longest and largest mountain chain on the earth. And yeah, like as pointed out by some students, like Iceland. Iceland is a useful is a location where the Atlantic mid-oceanic ridge is present. Atlantic mid-oceanic ridge is present in Iceland. Okay, so these are the features. These are the features of the ocean. Okay, so combining all these, there is the theory of plate tectonics. Okay, there's a theory of plate tectonics. So plate tectonics says that entire Earth's crust is divided into plates. Entire crust is divided into plates which are constantly moving, and they are moving due to convective current force. And plates move on something known as the asthenosphere. Plates move on asthenosphere. Just remember that plates move on the asthenosphere. And this plate tectonics says that interactions between plates can be of three kinds. Interactions between plates can be of three kinds. Convergent, meaning two plates are coming together. Divergent, meaning two plates are moving apart. And transform, Transform meaning plates are moving beside each other. And these plate interactions are what are responsible for earthquakes, mountain formation, for plateau formation, like basically a lot of the physical features, islands, formation of island arcs, formation of these like deep-seated earthquakes, the sea floor, then change the movement of continents from Pangea to the Earth we see today. All of these are formed due to plate tectonics. Okay, so then this theory of plate tectonics, three types of interactions, and the plates are moving on asthenosphere. Fine. Okay. Related to plates, some important facts which you need to remember. Okay, are the names of some of the minor plates which are there in the NCRT, like Cocos Plate, Nazca Plate, Arabian Plate, Philippine Plate. These plates and where they're located, you need to know. So Cocos Plate is between Pacific and Central America. Nazca Plate is between South America and Pacific. These you need to know. Like these facts can be asked, and yeah, like basically, I think these are at least from prelims point of view, these are what can be like really important from this section. Okay, I'll just type out the names once, like some of the minor plates: Cocos, Nazca, and Caroline. And I mean, you all already know this, but plates include both ocean as well as continent. It is not that ocean is separate, continent is separate. Both will have, like, both ocean as well as continent can be present on the same plate. Fine. So this is next. We'll just look at some rock interactions before we move on to climate. So for like minerals, the properties of minerals are very important, because these properties can also be asked in science and tech. Minerals can also be asked in science and tech. Okay. So for this, like I'll just quickly tell you what some of these properties are and what they mean. So you have cleavage. Cleavage property means how whether the mineral cracks as a plane surface or no. Okay. So cleavage is the property of a rock or mineral to be arranged as sheets. Okay. And if it is arranged as a sheet, when you break a rock, okay, whether it breaks in a straight line or no. So for example, if I take a chalk, all of you have seen chalk before, right? If I break a chalk will break in a straight line. Okay. Chalk will break in a straight line. Fine. So, but for instance, if I try and break some other like a pebble or something, a pebble will break irregularly. So, have you ever tried in school? You must have seen, no, teachers take a chalk and just break it like this. When you break a chalk, how does chalk break? It breaks as a straight surface. Okay, chalk, if you break, it breaks as a straight surface, as a plane surface. So that property is known as cleavage. Okay. So opposite of cleavage is fracture. Wherein in fracture, what happens is it breaks irregularly. So supposing you break any other mineral that you can think of, right? Suppose you break like iron, or if you break coal you must have seen, like in ironing places, press if you want to get clothes pressed, people take coal. If you break coal will break irregularly. So coal is known to a property of fracture. Fracture means it breaks irregularly. Next property is luster. Luster is the property of how it interacts with light. Okay. So basically, is it shiny? Is it gloss? Is it metallic looking? Is it glossy? This interaction with light is known as luster. Then you have streak. Streak is, supposing I grind the mineral, what color do I get? Supposing I grind the mineral, what color do I get? That is known as streak. And like the rest of the properties, I'm sure you've all heard of before, but like transparency, hardness, these are all properties that you already know. But these four properties, cleavage, fracture, luster, and streak, I think you might not have in case you did not know earlier, I thought I'll clarify these for you. Because again, UPSC will not ask direct questions, but it will test your knowledge. If you know these terms, you will have more knowledge and better ability to answer the question. And I'm sure types of rocks, everyone must have already done before. Like igneous rock. Igneous rock is formed due to lava. Then you have like sedimentary rocks by layering. When sediments are layered under pressure, metamorphic rocks under heat and pressure, rocks transform, rock cycle. Okay, like these all things I'm sure you have done before. Like what you should try and remember is the examples. So like I used to make a chart which is igneous. What are the types? Like granite, gabbro, basalt. Then you have sedimentary. Sedimentary, you have limestone, chalk, this sandstone, like that. Just remember the examples. So this is the initial part of geography we have completed. Okay, now let's look at climate. I'm doing climate before we do landforms because climate is extremely important. I hope like you feel like at least, so in an hour and in 1.5 hours we've completed the basics of geography revision. And anyone who has revised the notes and come, revised your notes, revised NCRT, revised GC Leon, would have been able to follow the class, I'm hoping. Fine. So let's now look at climate. So climatic regions, what I want you to try and do is prepare a sort of this chart or a table. I'll give you an example of that table. Let me try and, one sec, I'm going to share a picture with you. Yeah, I sent a picture to everyone. What you need to do to become really good at doing climate is preparing this chart, this table. Okay, can everyone see the table? I've sent the picture of the table. Can everyone see the table? I sent it on chat. I sent it on chat and I sent it as an image. Okay, I'll send it again. A lot of people are saying yes. Some people are saying no. Okay, wait, let me just send it to everyone again. Has everyone gotten it? So what you need to do is, it's there on, are you all opening it on laptop or no? If you're opening it on laptop, you should get it. Okay, but yeah, okay. Most people are saying they've gotten it. So what this like this type of graph or chart, I'll tell you briefly what all is there in the chart, and you can try and decipher it from that. Okay. So you have multiple zones. You have multiple zones in climate. Okay. Like you have equatorial zone, you have hot zone, temperate zone, cool temperate zone, alpine or this tundra zone. And based on these, you have various climatic divisions. Okay. So you have like what does the graph say? One sec. I'll just share this. I'll just type out the various columns. This is going to be hard if I can't share pictures. You need to try and prepare a graph. What do I call a table? A table with all these listed out. Has everyone at least gotten all the column headings? Okay, so you have climatic zone, you have latitude, climatic type, rainfall, and natural vegetation. What you need to do is you need to prepare from the notes. From the notes, you need to prepare a table like this. Those who can access the table, please like share it with everyone, or those who cannot see it. Okay, those who can access it, please share it. So, like for example, equatorial zone, right? Equatorial zone. What are some of the properties? That equatorial zone is between 0 to 10 degrees north and south. That it has hot, wet climate, and there's rainfall all year round, and it is around 150 centimeters of rainfall, 150 centimeters plus of rainfall. Sometimes, like generally, but 200 plus generally, what you can say. Okay, so this like table you need to prepare. What I will do for you now is I'll give you a quick overview, a summary of the of this climatic regimes of the world. Okay, and then we will try and look at some questions in case we have time. What you need to do as homework is read the climate chapter and prepare this table. Reason is, if you prepare this table, you can solve 80 to 90% of all climate questions. If you prepare this table like this, you can solve 80 to 90% of climate questions. I'll try and find a better way of sharing this picture with all of you, or sharing like a better version of this picture with all of you. But making such a table is very important. If you make such a table, automatically your climate questions, climate doubts will all get solved. Okay. So basically, there are around 11 or 12 types of climate in the world. You need to know what these climate types are. So first is hot, wet, equatorial. Let me just give you a quick summary, and based on that summary, we can then try and solve some questions. Questions are very important. If you can solve the questions, you're done with climate. Okay. So first type is hot, wet, equatorial. Hot, wet, equatorial, like I said before, more than 200 centimeters of rainfall. Okay. And the type of vegetation over here is equatorial rainforests. Where are equatorial located? As said before, equatorial rainfall, it is located between 0 to 10 degrees north and south. So what is the property here? That basically throughout the day it is constantly raining. Throughout the year it is constantly raining. And this leads to formation of that hot, wet climate. Hot, wet climate where it is constantly raining. What is the type of rainfall here? It is convectional rainfall. Okay. What is convectional rainfall? Convectional rainfall is when there is heating. When there's heating of water, water gets converted to water vapor, and then the water vapor on condensation descends down as rain. This is known as convectional rainfall. So hot, wet, equatorial region, there is convectional rainfall. And what are some of the unique properties of this region? What are some of the unique properties of this region? Unique property is that over here, there is the formation of canopy. Canopy. There's a formation of canopy. What does canopy mean? Canopy means that you have distinct layers of the rainforest. Canopy means you have distinct layers. You have really high trees, then you have shorter trees, then you have shrubs, then you have creepers. But basically, it is there as layers. Layers of vegetation is known as canopy. Is everyone able to follow this so far? What are we doing right now? We're doing revision of climate regions of the world. Related to this, there's also an important term known as selvas. Selvas is the Amazon tropical rainforest. So related to this, there's an important term known as selvas. Selvas is the Amazon tropical rainforest. Okay. And what is the type of like lifestyle here? Generally here, there is mostly tribals who live here as hunter-gatherers. Tribals who live as hunter-gatherers. For those of you who are asking about climate I'm revising from GC Lyon. I'm not revising from NCRT. Because NCRT climate is very, will not help you answer UPSC questions. NCRT climate is a good foundation, but it will not help you answer UPSC questions. So I'm doing the revision from GC Lyon. Fine. And last is temperature. Temperature in this region is 27 degrees. 25 to 27 degrees. And same temperature is there throughout the year. There is no winter. So fine, that is that's done with tropical hot wet climate. Next is the tropical monsoon climate. Tropical monsoon climate comes in the eastern continental part between 10 and 30 degrees north and south. Tropical monsoon climate is on the eastern continental part. So meaning China. This is also known as China type climate. Tropical monsoon climate, also known as China type climate, is in the eastern part of the 10 to 30 degrees north and south, meaning between the tropics. Tropic of Cancer, Tropic of Capricorn region, 10 to 30 degrees. Tropical monsoon, also known as China type climate. is present. Okay. So what are some of the features of this? Features first obviously are that the rainfall here is monsoonal. It is not convectional, it is monsoonal. Rainfall in this region is due to monsoon. Okay. So this type of climate is present in China, in Thailand, Laos, Cambodia, parts of India. And what are some of the weather conditions? Temperature here is between 27 and 32 degrees Celsius. Rainfall is around 150. Rainfall is around 150 centimeters of rainfall. And generally in this region, there's no distinct dry period. There's basically a distinct monsoon period. There's a distinct monsoon period. Like you see in India also, right? There's a distinct monsoon period. There's a time of year when the rainfall happens, and rainfall happens in the most. I've already shared the book list. I've already said that GC Leong is where I'm doing climate from. So if you revise GC Leong, this will all become much easier. So what are the types of trees? We looked at temperature. Temperature is 27 to 32 degrees. We looked at rainfall. Rainfall is 150 centimeters. And we looked at region. Geographic region is between 10 to 30 degrees north and south. And it is present on the eastern margins. Okay, it's present on eastern margins. And this is also known as like China type climate. So what are the types of trees here? Types of trees are deciduous. DECI. Wait, I'll spell. Okay, there's a doubt on how to read GC Leong. I've already mentioned this yesterday, but I'll repeat once. GC Leong, what you need to do is focus on areas which are not covered in NCRT. Like climate. Climate is in NCRT is only one chapter, 1.5 chapters. That's all. 1.5 chapters you cannot do for UPSC. So GC Leong, climate you have to cover from GC Leong. Okay. So deciduous. Why deciduous trees grow here? Because there's a distinct dry period. Like for example, India also rains for 4-5 months. But apart from that, you have a period where it is not raining. So deciduous trees grow, and deciduous trees, what do? They shed their leaves. Evergreen forests, why they call evergreen? Because they do not shed their leaves. But deciduous forests, they shed their leaves in the winter when rain is available is less. And what is the economic activity over here? Economic activity is mainly agriculture, very intensive agriculture, like you see in India, like you see in China, where rice is grown, sugarcane is grown, jute is grown. So very intensive agriculture is there in this region. Okay. And in climate, what you need to remember is also what is the alternate name for this type of climate. Okay. That tropical monsoon is China type of climate, right? Like these alternate names you need to remember. Because next section is Sudan or Savannah type of climate. Savannah type of climate, also known as Sudan type climate. Okay. So an important term for this, an important term associated with Sudan or Savannah type climate is transitional climate. Transitional climate. Is transitional climate. So Sudan type climate is transitional between the monsoon climate and deserts. So you can see that it will kind of have characteristics of both. It will have characteristics of deserts as well as characteristics of monsoon. So what is found here? Mostly vegetation found here is grasses, tall grasses. Like you see in these National Geographic and all these like channels, right? Like tiger hunting zebra, all that is savanna. All that is savanna type climate. Okay. So this includes the portion known as Sahel region. Sahel region in Africa has this type of climate. Sahel region is also very important generally because it's been in the news a lot in the past year. When I talk about places in news, I'll mention again Sahel. Okay. But Sahel region is very important because it has been in the news a lot. Sahel region has savanna type climate. So related to savanna, there are some specific names of savanna in different parts of the world that you need to remember. You need to mug up. I'll type it out. Just make sure you mug these up. There's no logic to these names. You just need to remember it. So Campos in Brazil. Brazil savanna is also known as Campos. Then you have Ilanos in Colombia. Okay, Ilanos. These are all types of savanna. Other chapters from GC Leong, mostly just climate. Climate in GC Leong is a huge section. It's almost 12 chapters, I think. Just climate, if you do from GC Leong properly, it's and landforms. Climate and landforms. These two sections are important from GC Leong. Climate is around 12 chapters, 11, 12 chapters that you need to do. And landforms, like glacial landforms, islands, then you have karst topography. These are all covered in GC Leong very nicely. Landforms also I'll do. Africa savanna is known as this Kano, Cano. Let me see. Is it exactly called Kano? No, it's not. Kano is different, but leave it. Okay. So these are some. Wait. Let's finish. I'll take 2-3 minutes extra. Let's try and finish this climatic regions of. Let's try and finish savanna, and then we'll do the rest tomorrow. But yeah, you have in Africa you have Kano and Salisbury. Kano, Kano and Salisbury, which are the savanna regions of Africa. Next, again, we'll fill the same temperatures, same temperature ranges. You have 24 to 27 degrees Celsius of in savanna region, 24 to 27. And rainfall is around 100 centimeters, around 125 centimeters of rainfall in this region. Again, even in savanna region, you have distinct wet and dry seasons. You have distinct wet season as well as dry season. And you have tall grasses in the savanna region. So tall grasses and short trees. Tall grasses as well as short trees. Important term here is parkland vegetation. Parkland or bushveld. These are associated with savanna. So if ever there's a question on parkland vegetation is associated with which climate, bushveld vegetation is associated with which climate, you need to be able to say that these are savanna. Similar to how canopy is only for equatorial. Like that, parkland vegetation is for savanna type of climate.